So hello students, I hope all of you go through my last lecture. Okay, so in today's lecture I'm going to discuss about the deviation through a prism of small angles. Okay, now here we consider one prism ABC. ABC is a prism. Now suppose a ray is incident on a prism with small angle of incidence. Okay, I is very small. If I is small, then R1 also is small. If R1 is small, then R2 also is small. Then angular immersion also is small. Okay, so we consider a prism which is refraction, in which the refraction takes place with a small angles. Okay, now see. Now first we consider face AB. Face AB of the prism. So for face AB, AB. Okay. So from Snell's law, mu will be equals to, what is mu? Here we know mu, sin A by sin R. From Snell's law we know mu equals to sin A by sin R. Since I and R are small, because I and R are very small, so we can write mu is directly equals to, we can write I by R. So it will be I equals to mu R, R1, so mu R1. I equals to mu R1. Okay. So this is for face AB. So for face AC, now we consider for face AC. Here in face AB, the light goes from rare to denser medium. Rare to denser medium. Now in face AC, what will happen? Light goes from denser to rare medium. Okay? Denser to rare medium. So for face AC, Snell's law will be mu equals to, since light goes from denser to rare medium, then it will be sin E by sin R2. Because here light is going from denser to rare medium. It is equation from principle of reversibility. Here, in this case, it is refractive index of glass with respect to air. Okay. For face AC, we have to find refractive index of air with respect to glass. That means, if you take the reciprocal, then it will be again refractive index of glass with respect to air. So, if you take reciprocal, then it will be sin E by sin R2. So here we can write sin mu equals to sin E by sin R2. Since E and R2 is small, so mu equals to, you can write E by R2. Okay. So E will be equals to mu R2. Give it equation 1 and equation number 2. Equation 1 and equation number 2. Okay. Now we know A plus del equals to I plus E. A plus del equals to I plus E is already got in previous topic of prism. So put the value of I and E here. So del will be equals to I plus E minus A, I plus E minus A. So it implies del equals to, place the value of I, mu R1 plus mu R2 minus A. Okay. So from here implies mu equals to R1 plus R2, you take mu common, minus A. So what is R1 plus R2? Again from previous case we know R1 plus R2 equals to A minus A. Okay? So there will be equals to A into mu minus 1. So this is the angle of deviation for a prism, deviation through a prism of small angle. Okay? So del equals to A into mu minus 1. Okay, you should remember this. Okay. So now I'm going to discuss about the dispersion. Okay, dispersion. So dispersion is a phenomenon of splitting of white light into its constituent color. Okay. So the phenomenon of splitting up of white light into its constituent color is called dispersion of light. Now, when a white light is passed through a prism, okay, then it will split into its 7 color. We know the 7 color is deep shade, violet, indigo, blue, green, yellow, orange, red. Okay. So when a white light is passed through a prism, then it will split into its 7 constituent color. Here comes our prism. It passes white light, and after reflection through prism, the white light will be split. White light will be split into its 7 color. This color is VGO, 7 color. Okay. Now white light means we use the white light, mercury light. We can use mercury light as the white light. So in laboratory we can see in spectrometer also we can see there is instrument named spectrometer. If we pass the mercury light through a prism, then we can clearly see the 7 color. Okay. Now this phenomenon is known as dispersion. So now why dispersion occurred? Why dispersion occurred? First of all, we know that the wavelength of red light is much greater than wavelength of violet light. Wavelength of red light is greater than wavelength of violet light. Okay. So the refractive index of a material will be different for different wavelength of light. The refractive, you should remember, the refractive index of different light, different color of light will be different. One scientist named Cauchy gave one formula about refractive index. The formula is mu equals to A plus B by lambda square plus C by lambda to the power 4. A plus B by lambda square. This is Cauchy's equation, you can try, suppose. Mu equals to A plus B by lambda square plus C by lambda to the power 4. What is ABC? ABC is constant. ABC is constant. ABC is constant. Okay. Now you see. Now from this equation, you see if the wavelength will be get greater, then the refracting index will be the less. Understand? If the wavelength is more, then refracting index will be less, because wavelength is in its denominator term. So from this equation, we can say that the refractive index of red light is more than refracting index of violet light. From this equation, because the wavelength of red light is greater than wavelength of violet light. If the wavelength of red light is greater than wavelength of violet light, then from this equation we can say the refracting index of red light is smaller than less than refracting index of violet light. Okay, up to this. Okay, now see. Now we know for small angle prism, del equals to A into mu minus 1. We already proved this for small angle prism. Okay, for small angle prism, del equals to A into mu minus 1. You got it? Okay. Now see from this here. See from here. Okay. If mu will be greater, then del also greater. If mu will be less, then del also less, because A is constant. A is the angle of prism. For a prism, angle of prism will be constant. Now for ray light, del R will be less than del B. Del R will be less than del B. Del R will be less than del B. Now see, what is del R? Angle of diffusion of red light. What is del phi? Angle of diffusion of violet light. So from this we can say that the angle of diffusion is red light is less than angle of violet light. So here you say the red light will be, this angle of diffusion is less. This angle of diffusion, okay, is less. This violet light, this is more. This is the angle of diffusion of violet light. This is the red. That's why, because of the different refracting index of different color, the dispersion phenomena happened. Dispersion phenomena happened. Okay, is it clear? Okay, understand? Because of, again I say, because of the different refractive index of different color, the dispersion phenomena will happen. Because of different, first if you know, okay. First you have to know, first you can say that the different colors have a different wavelength. Okay? Then after this, for this formula, for this equation, mu will be less for longer wavelength, mu will be less for longer wavelength, and mu will be greater for shorter wavelength. Now consider mu are there. Red light and violet light, we know the red light, wavelength of red light is longer than wavelength of violet light. So refracting index of red light will be lesser than refracting index of violet light from this equation. Okay, if the refracting index of red light is less than violet light, from this formula we can say the angle of minimum diffusion of red light is less than angle of deviation of red light is less than angle of deviation of violet. Because of the different angle of deviation, we get the different color when we pass white light through a prism. Okay, so this is the cause of dispersion. So my last topic I have given that refraction through a small angular prism. Small angular prism, I forgot to explain. Small angular prism is, this angle is small. This angle is small. Okay, this angular prism is small. So if the angular prism is small, then angular incidence also is small, and if the angular incidence is small, then angular refraction also is small. Okay, so this is about the dispersion. This is about the dispersion. So now I am going to discuss about the angular dispersion and dispersive power. So first, what is angular dispersion? First is the definition. The angular dispersion for any two colors may be defined as the difference in deviations suffered by two colors in passing through the prism. Okay. Now when a white light passes through the prism, then we already know that what will happen? Dispersion will happen. Okay. Now dispersion, why dispersion happen? Because of the different angle of deviation or different refractive index. For different refractive index, the different color of light have the different deviations. Now if you consider two color, suppose we consider violet and red. So violet will be the more deviated than the red. Okay. Now the difference between their deviation angle of two colors is known as the angular dispersion. Here you can see, consider white light and white light pass through a prism of angle, suppose consider A. Okay, and after passing through a prism, dispersion occur means we take three colors: red, violet and yellow. Okay, red is the topmost color and violet is the lowermost color. That means violet has the more deviation angle. Now this is the angle of deviation of violet color, this is the angle of deviation of red color, and this is the angle of deviation of, suppose yellow color we take the mean deviation, suppose to consider for these two colors we take this. Okay. Now the difference between this violet and red, consider suppose we take violet and red. So this much is violet. If we subtract this angle of deviation of violet light from red light, then we will get this. Angle. Okay. So this angle is called angular dispersion. That means the difference in their deviation angle. Okay. So for this diagram, theta will be equals to del v minus del r. Del v minus del r. Del v is the angle of deviation of violet light and del r is the angle of deviation of red light. Okay. Now we know del v equals to, we can write a into mu v minus 1, and what is del r? A into mu r minus 1. Okay. So theta will be equals to a into mu v minus 1 minus a into mu r minus 1. If you take a common, then it will be mu v minus mu r. Mu v minus mu r. So this will be the angular dispersion. Angular dispersion. Theta equals to a into mu v minus mu r. Just remember this formula. Now we will discuss about the dispersive power. So dispersive power is defined as the ratio of angular dispersion for those two colors to the mean deviation. This is the ratio of angular dispersion to the deviation by mean light. Mean light means for red and what is the mean light of red and violet? Here we consider mean light of red and violet is yellow, and its angle of deviation is del. Consider angle of deviation is del. Okay, del. So dispersive power will be, suppose if consider omega, we take the dispersive power as omega. So omega equals to what is the angular dispersion of red and violet light, theta, and what is the deviation angle of mean light? That means for violet and red, the mean light will be yellow. For violet and red, the mean light will be yellow. Between violet and the angle of deviation, light deviation will be yellow. So for yellow, the deviation angle is del. So it will be theta by del. Now what is theta? We already got theta. How much? A into mu v minus mu r. A into mu v minus mu r, and del you can write a into mu minus 1. So a cancel, so it will be omega equals to mu v minus mu r, capital mu r divided by mu minus 1. So this is the dispersive power of a prism. Okay, we denoted the dispersive power by omega. Okay.